This meeting is being recorded.
All right, so this is the Whiz Kids regression analysis. I'm Michael Banks.
I'm Rachel Lee.
I'm Isaiah Rhodes.
I'm Kevin Sosa.
I'm Erica Brown.
I'm Akila Hawthorne.
And we're going to show you our regression analysis for the prediction of a grade based off the Accounting 200 class that Dr. Wilson had previously. So me and Erica were responsible for doing the data, getting it ready, getting it set up. Rachel and Akila were responsible for the correlation analysis, and Isaiah and Kevin did the regression analysis. And everybody can talk a little bit about what they did and kind of go over all the numbers to give you a breakdown of what everything is. Me and Erica did the data, as you can see. When we first acquired this data set, everything needed a value. If there wasn't one given, we could assume that the assignment was not done, or they did it and got nothing correct, for which they received the 0 for. We went through and added zeros, as you can see all through here. So everything needs a value when you're doing a regression analysis. And this is one of the first major steps in making sure that you have the correct data to run your proper regression and correlation analysis. While doing this though, we noticed a few things. One of the first things I noticed was a pattern. If you look at the total points earned, and look at the bonus points that were earned or completed, you'll notice that pretty much everybody who did that changed a letter grade. When we were looking at some of the data stuff, that's one thing that I noticed was that if you were to take this out, you're going to affect your grades that are posted. And when you run the regression analysis, there's a maximum point value that you have to have, of which is 500. We discussed it, and I made the point that if you leave it, you need to make that value 550 instead of 500, because in my opinion, it skews your numbers. Whereas you are only graded on 500, but there's a possibility of 550. And if you change that, if you change it to just 500, I think you need to remove the bonus points, which we didn't. We left it. We changed ours from 500 to 550 and left the bonus points, as because you could possibly make 550 total. Now, Erica, you were mentioning a few things as well about the data set, correct?
Yes, so I saw a pattern in the people, this is before we ran the correlation. So I saw a pattern in people who did not participate in the lectures or complete the assignments, and they received a 0 for it, or they did poorly on it. They also did poorly on their exams, which also led them to having a lower overall grade. And then secondly, so this one, I wouldn't say is a big data set. It's more on the smaller side, but with any big data set, the 3 V's will be applied. So in our set, it's a smaller one, but variety is basically seen with the grades that were used for the correlation. And the velocity is basically how quickly things can be transformed or seen. So I came to the conclusion that the grades, which are basically the students, but it was covered for privacy reasons. But you can find any student on here and find any of their grades, find their overall grade basically through the velocity of this Excel chart.
So pretty much what you're saying, everything is accessible.
Yeah.
Good. Okay. All right. Well, then we're going to turn it over to Rachel and Akila to go over our correlation analysis. All right, guys.
Okay. So I wanted to start off by like saying, what is a correlation analysis? Why do we use a correlation analysis? And what we use the correlation analysis for is to find the independent variables that are highly correlated with the dependent variable, with what we're trying to predict. So also that's the first objective. Then the second objective is to find a multi-collinearity, I think I said it right, which is obviously when one of our independent variables is highly correlated with another independent variable. And you don't want that. You have to pick one or the other. Usually it's the one of higher value. And then I think I'm going to pass it off to Akila. Oh, I did have one more thing. He mentioned in our comment section a question that he wanted me to try to formulate an answer for as we were going through module 2. And the question was, how can we use data bridges to make contracts more meaningful for Target? So running a regression analysis is a great way to do that. We can go through and we can run and predict the possible profits we can make off this contract. This could give us, negotiations if we know that we need to negotiate a little bit further, or if it's going to benefit us way, way better.
So you could probably also too, when you're doing that particular instance, comparing contracts, when you run a correlation analysis, you can actually see if there's any correlation in doing, contract X, Y, or Z versus doing A, B, or C.
Oh yeah.
It's definitely a very useful tool to be able to do.
Oh yeah. And then I think I'm going to pass it off to Akila so she can explain what these numbers are and what they mean.
Yeah, so I was just going to talk about the numbers. So we highlighted all the highly correlated variables blue, and we decided to bold all the ones, the independent variables that are highly correlated with each other. And the green ones are the independent variables that aren't highly correlated with each other.
Okay, good. I just want to speak real quick so you can actually see the numbers real quick, and we can kind of explain it. Like Akila was saying, these are our strong independent variables on this side. These are the ones here that have the multicollinearity. I can't say it either. And then these are the ones that don't have, they have a strong correlation, but it's not too strong that we can't use them.
Right.
So just want to make sure we see these here.
And then at first, I wanted to mention about this little error that's coming up in the maximum possible score column. Before I read the announcement where he said that was acceptable to do, I was sitting here freaking out for like me and Akila were sitting there freaking out for an hour, wondering why this table was doing this. And so we took it out and it worked fine. But then I was scared because I remember in his PowerPoint video, he said, use all the numbers. And so I was like, okay. And so then I saw it was acceptable and I was like, oh goodness, thank God. But that's why it does that. So.
Right. That'd be this column right
Yes.
here. Yep. Okay. And Isaiah and Kevin are going to tell us about the regression analysis.
Yeah, we had the regression analysis, and what it means, why regression analysis is important is because it helps determine which factors matter most, which it can ignore, and how those factors interact with each other. The importance of regression analysis lies in the fact that it provides a powerful statistical method that allows a business to examine or the relationship between two or more variables. And also this running the regression analysis also helps like big companies to predict like just not only just the grades, but other stuff like their inventory and anything like that, and a review and understand on how different variables impact all these things as well. And let me see. I think Isaiah, you were talking about how let me see,
The
I
R
can't see.
square. I was going to talk about
Yeah,
the
the
R
R
square.
square.
R square is how much the dependent variable is affected by the independent variable, or how much they're correlated in this case. Our independent variable would kind of be your final grade, or your dependent variable would be the final grade here. And the independence would be, for us, we chose the pre-lecture chapter 11 and exam 1 because they lacked any sort of multi-culinarity. That's a hard one. So I got A3, that's a strong correlation over 80%. That was like our number, and when we saw that, we were happy with it when we got that.
Yeah, so if we look at it, it'll be that number right there. It's highlighted.
Yeah. And then also we have the significant F. Less than 0.5, then this is a good equation. So we got it 0, 0, 0, as you can see.
Yep.
I meant to say 85 earlier. I'm sorry. I'm sorry. I'm looking at some notes too. Yeah. And then we use we use some of our numbers from the coefficients down at the bottom to find out if we did good on these grades, how well it would correlate and what we would get in the class. So you can see final grade there. We took our y-intercept coefficient first, which was the gimme. And then what we did is we took our pre-lecture, our coefficient, and we multiplied it by the weight, or that's the kind of the weight of the grade. So for a pre-lecture exam or pre-lecture chapter 11, you can get a 25 as the max grade. And so if you could click on the cell, you kind of see the little math we did there.
There you go. Yeah.
Yeah, 20. Yeah, you see we did 25 times the coefficient. So that's kind of the points that the system gives. And then you add that with the exam 2 coefficient times the amount of points you can get, which is 100. And then if you go down to final grade and you go to the right, it's 520. That's what you get. And it's kind of out of 550 is the final grade we chose, as Michael talked about earlier.
So your 520 is a combination of all three of these numbers, correct?
Yes.
Okay.
Yes. And we found out that if you got 100 on both of those assignments, that there's a very strong chance you would get a 94 point, or 94.5 in the class. A reason for this may be exam 2 might separate the people who did well in exam 1 just because it might have been the intro, kind of getting your toes wet into the class. Exam 2 might be where, the people actually know their stuff and study, start to really like do well, exceptionally well again, versus the people who kind of like level off after the first test, maybe go from getting an A to like a C on the second test because they thought they could, it'd be the same easy. And those people kind of study the same amount of hard every test. So there might be a correlation. Way you can use this in like large scale data is, let's say somebody buys one product and they buy another. You might find a correlation between those two products and the amount of money they spend, or if they buy a certain amount of products or even another product, like what's the percentage? And you might, run ads to that person for a certain other product. It doesn't have to be just grades.
Yeah.
And I forgot, if we want to go back to the correlation analysis just for a second,
Sure.
I was going to just explain for a second how we came to this table right here. Pretty much all we did was take the data that Michael and Erica had put together for us, and we took all that, went to the data tab, went to the correlation analysis, which is inside the data analysis tool pack up there. Where is it? Oh, it's up there, the data, yeah. And you just up there and you press the correlation analysis, make sure all the numbers are chosen, and it gives you everything you need.
Right there.
Yeah.
So
And
also,
then I'm sorry.
I'm not, go ahead.
I was just gonna throw in there that the numbers that we used as like a range for our high correlation started at 0.7 and went all the way up to 0.99. So I wanted to make sure so you knew what kind of range we had in doing it. So just to give you a full idea, I got kind of off track there for a minute.
Also, too, in our data, we did move some of the numbers around a little bit, or the columns around. When you run your regression analysis, you want your columns together. It makes it easier to run, so you're not, having to jump over different ones and pick out certain ones. You can just grab it and go. Because if you don't do that, you're gonna run the risk of running into an error. So that's why they're not all in order right now.
Yep.
So just to point that out.
Yeah.
So, well, I would say regression analysis are really good. You can predict pretty much anything with them as long as you
Yes.
have the correct data.
Yeah.
As you can see, with data sets like this, and even bigger data sets, companies like Target, even I could also see it pretty much in any store. But the one that comes to my mind would be probably any kind of car manufacturer, to see what kind of cars are selling, when they're selling, who's buying them, that kind of thing. Are they buying new ones? Are they buying used ones? Are rebates being used? That kind of thing kind of jumps out to me when doing a regression analysis, to be able to pick out certain things to look at. And there's a ton of more examples, but like I said, that's just one that jumps out to me. You could also probably do, NFL teams, college teams winning. Like I said, you could just run a gamut with pretty much anything with that.
Yeah.
Mm,
I think, like I said, that it's really beneficial to Target in doing contracts. I think it would make it more meaningful for them. Thinking if there was anything else. This, I will say, this module did make it a lot easier for me to like fully comprehend data bridges, because I don't know why, but that was really hard for me to comprehend. And then like once you're looking at like the data right here, you're like, oh, well, that makes sense. Like, and you could really put anything into data and transform it and use it for regression, as long as it's, usable. But
Right. Yep. And as you can see, this is just a small taste of it. With bigger companies that have the bigger data sets, it's going to take a minute to go through all this different information. I would say if you take this information that we have and multiply it by a million, probably more than that, but you can see where it would be tedious to go through and make sure all your data has to be correct. Make sure you pull out the right kind of variables to make sure there's no errors in it when you run, your correlation analysis. And again, you get to kind of play with the numbers a little bit. There's a little bit of wiggle room in there. But you don't want to skew it too much, that way your numbers are off.
right.
So, all right. That's pretty much it on our regression analysis. Anybody else have any final comments before we end this?
I think we're good.
Good. Okay. All right. Well, this concludes our regression analysis.